What we're going to do today is we're going to review what we did last week and this week. So I'm just going to pick one problem from each of the different sections. So looking at section 1, what we're going to be doing is graphing and stating the domain and range. I'm going to pick letter C. First step that I want to do is I want to add the -3 on both sides. Or just add 3 on both sides. That gives me f of x plus 3 equals log base 2 of x minus 1. Now I need to get rid of the base, so what I'm going to do is I'm going to do a base of 2 on both sides of the equation. And remember, whenever we have bases that are the same, it always becomes 1. So what we do is we get the x minus 1 by itself. So x minus 1 is equal to 2 to the f of x plus 3. And I'm going to continue to get the x by itself, so I'm going to add the 1, and that gives me x equals 2 to the f of x plus 3. I'm going to add 1. So I know that my vertical asymptote is going to be x is equal to 1. And then I'm going to come up with my table of values. I'm looking at my exponents, and I see a plus 3, so I'm going to put -3 for the y. And then that means -4 and -2. When I plug in the -4 plus 3 gives me -1. So I flip it. That becomes 1/2 plus 1 is 1.5. When I plug in a -3, -3 plus 3 is 0. Anything to the 0 is 1. So that gives me 2. Then when I plug in a -2, what's going to happen is that gives me 1. So that's 2 plus 1, which is 3. So I'm going to draw my graph, my x and y axis. And I have my vertical asymptote, which is at 1. So I have a vertical asymptote at 1. I have 1.5 and -4. I have 2 and -3. I have 3 and -2. And that right gives me my log equation. Now what I need is the domain and range. So the domain is going to be from 1 to infinity. The range is going to be -infinity to. Now looking at the solving, I'm going to do 2 of these. One where we have values for the base, either 5, 1/3, or e. So I'm going to pick letter A. The other one where we have natural log, log, and log base 3. I'm going to do the natural log. So I'm going to go over A and D. When we're looking at letter A, our first step is going to be add the 3. So what we have is 5 to the 2 minus x is equal to 16. Then what I have to do is I have to get rid of the base of 5. So I'm going to do the log base 5 on both sides. This once again becomes 1. We take our exponent, bring it to the front. 2 minus x times 1, of course, is 2 minus x. Change of base formula, if you remember, is log of 16 divided by log of 5. When we put that into our calculator, what we get is 1.72. Then I'm going to subtract the 2. So I have negative x is equal to negative 0.28. Then I'm going to change the sign. So x is equal to 0.28. Now, if we're looking at letter D, what I want to do is I want to get rid of the natural log. And remember, natural log is the same thing as log base e. So in order to get rid of a natural log, I'm going to do a base of e. Whenever we have bases that are the same, it becomes 1. So I have x plus 1 equals e to the 5th. E to the 5th is 148.41. So when I subtract the 1, I get x is equal to 147.41. Now looking at the second page, just gonna do a quick review of exponents. We're multiplying, so 8 times 9 is 72. And remember, when we multiply, what we do is we add the exponents. So what we have is 4 plus a half is 4.5. I'm going to write it as an improper fraction. So that would be x to the 8, 9 over 2. This is a 1, this is a 6, so that's y to the 7. Now, if you remember from the very beginning, what we're doing is we're writing each in logarithmic equation. This is our base number. So we're going to do log base 4 of 16 equals 2. Now, for number 5, what we're going to do is we're going to write it in an exponential equation. So what we have is our base being 5. So I'm writing a big base of 5. The x is our exponent. And the 15 is the number by itself. Now looking at question 6, what we're going to be doing is we're going to be solving. So the first thing I'm going to do is I'm going to take this log equation, I'm going to write it as an exponential, similar to what I did just above here. Taking my base number 2, I'm raising it to the x, and it's equal to 32. When we solve exponential equations, we look for a common base. So my base is 2. 2 to the 5 gives me 32. Ever the bases are the same, they cancel. So what I get is x is equal to 5. Now, looking at number 7, what I'm going to do is I am looking at the natural log, and I'm going to write one single natural log. So I have natural log. This would be e to the 2/3 times e to the 1/3. And then what I have is times x squared. Now notice that we have two variables that are the same, so that's natural log of e to the, if we add the exponents, that would become 1. And then what we have is x squared. Now, e to the 1 is just e, and that of course becomes just 1 because it has a common base. So what we have is 1 plus natural log of x squared. Number 8 is the converse. What we're doing is we're expanding it. So we're writing a log for each of them. Log of 10 plus 1/2, because that right there is a square root. Log of a, because this is in the denominator, we're writing a subtraction sign. This is a 4, so I'm putting the 4 in the front. Log of b. We know that the log of 10 is 1. So I have 1 plus 1/2 log of a minus 4 log of b. Last one I'm going to do is simplify. Each one of these, when we're evaluating them, what we're going to do is we're going to look for a common base. So if we're looking closely, what we see is we see a common base of 7 right there. So that becomes log of 3 to the log base 3 of 9. Since those are the same, it becomes a 1. So we have a squared. We know that 9 squared is 81. So log base 3 of 81. We also know that 81 is really 3 to the 4th. Once again, we have common bases. That, of course, becomes 1. So our final answer is